First, just reviewing some vocabulary. This is actually some of the same stuff we wrote at the top of those last notes that I told you should check out for the quiz. Okay. A circle is the set of all points in a plane that are equidistant from a given point called the center of a circle. That's exactly what we wrote as our definition last time we were together. Okay. A circle with a center P is going to be called circle P, and this is exactly how we would denote it. Okay. A segment whose endpoints are the center and any point on the circle, so the center and anywhere on here, is a radius, right? If it goes from the center to the circle. A chord is a segment whose endpoints are on the circle. Something like this. It's got an endpoint here and an endpoint here. And then our diameter is a special kind of chord because it does have both of its endpoints on the circle, but a diameter is also going to go through the center, right? Okay, so a couple of new definitions, okay? So it says when a minor arc and a chord share the same endpoints, we call the arc of the chord. Okay, and what they are referring to, so you see this chord is drawn right here on the figure. Here's its endpoints. This arc has the same endpoint, so that's what it's referring to. Okay, when the chord and the arc share the endpoints, we call it the arc of that chord.
So isn't the arc of the chord question on this one?
You could use it. You could use it, but we had enough information known previously that we didn't have to use these theorems or that one. Okay. All right. Next, a polygon. Polygon is an inscribed polygon. If each of its vertices lie on a circle. Okay, so as long as that shape has all of its vertices on the circle, it is inscribed. So basically the opposite of circumscribed that we learned the last time, right? That was when the figure was outside. Here is where the figure is inside. Okay. All right, and then we've got a few new theorems. So remember, these are just basically rules that we can use from here on out when solving problems. The first theorem says that in a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So what they're saying is if you were given a picture like this and there's two chords drawn inside your circle, just like they have here, if they tell you that those two chords are congruent, then you can automatically know this arc and this arc are congruent. Okay. All right. Second rule or theorem says that in a circle, if a diameter is perpendicular to a chord, then it bisects the chord and its arc. So what does bisects mean? Cuts it exactly in half, making the two pieces congruent, right? So they're saying if you've got a diameter, which would be EG in this case, and a chord, which would be FD in this case, and they tell you they're perpendicular, they would do that by drawing the right angle, right? Then they're telling you that chord has been bisected, or basically that these two pieces are congruent, okay? Not only are those two pieces congruent, the arcs of those two pieces are also congruent. Okay? So FH and DH are congruent, and the arc FG and DG are also going to be congruent. Okay? All right, and then our third theorem says that in a circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. Okay, so our chords would be A, B, and C, D in this drawing. If they in some way tell you, okay, this line is the exact same distance from the middle as this line, then I will automatically know that these two lines are congruent. Okay? If they are the same distance from the center. So they'll probably mark it by saying those two pieces have to be congruent. And then in turn, if we know these two chords are congruent, right, from that first theorem, we know that these two arcs would also be congruent. All right? Okay, so let's use those rules on the back to help us solve a couple of problems. Okay. All right, so it says in circle P, the line segment PQ and the line segment RM are perpendicular. I want us to use this figure to answer these questions. Okay? So, PQ, this line here, and RM are perpendicular, meaning they form a what angle? Okay. All right, so according to our rule on the front, if this line and this line are perpendicular, then it should mean these pieces and these arcs congruent. Right. All right, so the first thing they ask is what arc is congruent to the arc QR? QM, because like we just said, if they're perpendicular, then that means they were bisected, right? So because PQ is perpendicular to RM, we know it's going to be the arc QM that's congruent. All right. Okay. On B, they said that the segment PR is 13. So this piece over here is 13. And that RM, this entire chord, is 24. And they want us to find PO, this piece here. Okay? Well, what do we have right here? Right, triangle. And I'm looking for PO, right? That's my unknown piece. Do I know what this segment is? 12, right? If the whole thing was 24 and we said these pieces are congruent, this has got to be 12. So how could I maybe find that missing side? So I want to know this piece right here. I know this one and this one. How could I find it? The heartbeat method? Well, it would be the rabbit on this one because, well, I guess you could do 12. But you also could just do Pythagorean theorem, right? Either of those would work in this case. So, honestly, this one is one of those Pythagorean triples that we should be memorizing.
No.
Huh?
Yeah, 9.
No, but you are close. That is one of the other ones. Not the 9, 12, 13, but 9, 12, and something. Okay. So on this one, if we don't have our Pythagorean triples memorized, which one's the hypotenuse? The 13. Okay. So then I would have my unknown side, or my x squared, plus 12 squared equals 13 squared. Well, 12 squared is, and 13 squared is,
69.
and what is 169 minus 144? And what's the square root of 25?
5.
Okay. So x, or they called it PO, is 5. Again, Pythagorean triple. So if you have this one memorized, this one is super common. You don't even have to do Pythagorean theorem. You would just see it and know it's a triple. Okay? All right, and then they want to know a segment that should be congruent to PM. PR, why?
Because they're congruent triangles.
They're both radius.
They're both a radius, right. It is an isosceles triangle, but the reason we know it's an isosceles is because those are both radius, so they have to be the same size. Very good. All right, so PR, because both are radii. All right. All right, number 2 says, suppose a chord of a circle is 10 inches long and 12 inches from the center of the circle. Find the length of the radius. So they already drew it out for you over here. Kind of similar to what we were just looking at, right? I know 2 out of the 3 sides on this triangle. So what's missing? This is 13, right? The Pythagorean triple that we just talked about on the problem before. And if we didn't know it, of course, we could use Pythagorean theorem. But it is our hypotenuse that's missing this time. So if you were to do it, 5 squared, 12 squared, r squared is over here, right? But like you guys just said, we already know it's 13 because it's a triple. Okay? All right. Okay, this next one says, suppose the diameter of a circle is 30 centimeters long and a chord is 24 centimeters long. Find the distance between the chord and the center of the circle. So on this one, they didn't draw a picture for us, so we're going to have to draw our own circle. Okay, and there's my center. Okay. They said that we have a diameter. They did not specify where that diameter is. You could draw it wherever you want. Okay? So maybe you draw it diagonal through there, something like this. Okay? Well, if the diameter is 30, what do I know this half and this half must both be? Okay? All right? They also said there's a chord that's 24 centimeters long. Again, they did not specify where I have to put this. So I'm going to draw it in a place that would be something that could help me form a right triangle, because that's how I know how to find missing sides, right? Okay, they said this chord is 24 centimeters long. They want to know the distance between the chord and the center. So from this chord to the center is what they're looking for. So do I know how long this piece right here is? 12, right? Because I drew this line to be perpendicular, and if it's perpendicular, it bisects. So if it's 24 long, this should be 12 and 12. Okay, so I got my 12, I got my 15, I got my x. What are we going to do to find the missing side?
15 squared minus 12 squared equals x squared.
Yeah, because 15 is my hypotenuse this time, so it would be over there by itself. So if you actually wrote this out, this is what you would have, and if you want to get x squared by itself, you got to subtract the 12 squared. Okay? So what is 15 squared minus 12 squared?
81.
81, and the square root of 81 is 9. So x is 9.
Let's put that.
Yeah, that was the one you were going for earlier, I think, when you were talking. All right, last one. They want us to find the length of AB. So that would be this line right here. Okay. So this line that they gave me, I said it was 6 long. What kind of a line is that? A radius. So any radius should be 6 long, right? So if I drew one from here to here, also 6. Okay? They told me this arc is 120 degrees. So what do I know my central angle is? 120 degrees, right? Now, I want to know the length of this line, but I need to form some kind of a right triangle in order to do that, because all of our rules are for right triangles. So I'm just going to draw a line that's going to form that 90-degree angle. Okay? So yes, now it will be a 30, 60, 90, because this was 120, and I just cut it in half. So now it's 60. This is 90. This has got to be 30. Also, when I drew this perpendicular line, I now made it to where this piece and this piece should be congruent. So if I can find one of them, then I can find the whole line, right? So I can draw this a little bit bigger. It's kind of small over there. So this is what I have inside of there. It's kind of small. Okay, I have that this side is 6. Okay, well, in a 30, 60, 90, what do we label the side across from 30? Across from 30 is X. Across from 60 is
X.
and across from 90. Okay, so 2x is apparently equal to 6, meaning x must be. So what is this side over here? Good. Okay, so this piece is 3 square root of 3. They want to know AB. So what should I do?
Multiply with 3.
So that would end up giving me